Hello, this is me comparing IPv6 to IPv4 for better schools, business, or tertiary education institutions such as EDUFOS. To better understand IPv6 and why it's better than IPv4, we first have to go look back at IPv4, and then we look at IPv6, and then we weigh out the upsides and the downsides to it. Let's start with IPv4. IPv4 is an internet protocol that was developed by DARPA and was first deployed for production on the SATNet in 1982. It was then formally recognized in 1983 on the ARPANET. Completely mispronouncing that. It sits on the network layer on the OSI module, which is the third layer, and its main purpose were as listed, giving unique identification by assigning 32-bit labels to every device, for routing packets and the correct drop points, or to the correct drop points, providing a logical system for data routing and forwarding with routers and switches. And now with IPv6. Like IPv4, IPv6 is also an internet protocol and serves, that's a spelling mistake, and serves nearly the same purpose as, it's also a spelling mistake, as IPv4, but some key differences are listed below. IPv6 is much newer than IPv4 and was launched on the 6th of June 2012. IPv6 is also much more scalable than IPv4, as there is much more integer. There was much larger integer limit that it can use. So if you compare the two IP versions with their downside, you can see IPv4, since it has a max of 32-bit addresses, it is limited to only 4.3 billion unique addresses. IPv4 has no mandatory security features on the protocol level and requires configuration like IPsec or VPNs for encryption, which may slow it down a lot. It's very cumbersome, not all recommended. It lacks native support for mobile devices and it's insufficient for most routing cases. It often requires manual configuration or DHCP. Now to move on to IPv6, not all existing devices or computer systems, operating systems, even older legacy systems do not have the support or at all compatibility with IPv6 since it's so new. It also has a very high information cost because you can have to probably, if you're on a legacy system, you have to buy a whole new system or upgrade everything to the support of IPv6. So it can be very expensive, and you also have to understand it better. So it also has a much higher difficulty compared to IPv4. That's because of the hexadecimal. It's difficult. Then we see the upsides of the two IP versions. IPv4 supports by nearly everything. Your calculator probably has IPv4 configuration to it. It's highly compatible even to legacy hardware. You can see that. Since it uses the 30-bit integer limit, it's easy to understand since it can only go up to a certain number. The hexadecimal is not included here at all. And since IPv4 is way more common than IPv6, since most people still have legacy systems or older computers, older phones, or no phones at all, which in case this doesn't matter to them. And it's just cheaper to run than newer systems like IPv6. Then we move on to the IPv6 upsides. It uses a much longer bit address, 128, which, to put in perspective with the hexadecimal it uses, it has about 340 undecillion, or in this case 340 million times a trillion, I believe it is the correct thing. It has inbuilt authentication and encryption by the IPsec. Although you have to manually configure the IPsec, it is built in and you can use it. It features a simplified header for faster processing and That's a spelling mistake, and doesn't need the network address translation. So it's better for direct end-to-end connections. It's also much more efficient for routing and auto configuration, and it's very easy to scale with. Now the IPv6 adoption for the smarter EduForce, like EduForce, evaluation of IPv6 to ensure mobile devices and cloud computing for scalable smart campuses. Yay, more read. I'm not supposed to read. The challenges with the transition between IPv4 and IPv6. Well, if I was an IT person at a business or at the campus, I would cry if I had to look at this. So let's start with the easiest one and go to the much larger ones down here. Compatibility issues. Not all, like we said, not all legacy hardware can support IPv6. That's the same with the software. The software doesn't support it. Well, go cry in a corner. And if they do support it, it's probably in a further update. Most likely not the one you have. If you have a legacy system, if you have something from 2012, you might have it. But if from 26 and onwards, you most likely already has IPv6 support. Training. Probably where I would go cry in a corner. IT staff will need to be trained for IPv6 subnetting and routing. IPv4 was enough for me, thanks. IT staff will need to learn the new 128-bit integer addresses with the hexadecimal format, which is tough as is. I don't like it. I have to do it anyway. So that's the big training thing here, especially the hexadecimal format. Dual deployment load. Both running IPv4 and IPv6 together at the same time doubles the administrative load, so see why admins never go outside. And then it's just more difficult to run because there's so many more security protocols in place for these protocols. Wow, I said protocols in one sentence. So in essence, it's just a lot more work to be done. So no, not fun. Not fun with that. That's not a fun one. Security risk concern. Since IP6 is much newer, it's introducing new types of attacks like Slack attacks or SLAAC, I believe it is. And then all the firewalls in the servers, especially Windows servers, because I had to deal with that, had to be redone for IPv6 traffic. Even though IPsec is built in, it still has to be manually configured and fiddled with to make sure you have the encryption and the authentication set up for the IPv6. So this and this seems to be, and this one as well, seems to be the most fun the IT people have ever, these three. Now, let's move on to the fun part. Why must EduForce adopt IPv6? Well, the future of EduForce will hopefully consider IPv6. I'm sure they really are there. Well, it's simple because IPv6 allows the campuses and other people to connect to the learning portal, the LMS, from anywhere around the world. So it's remote access, as seen here. That's not the color I want. Blue. I know we get green, yeah. Such as secure remote access, because both in the IP6 support in IPv6 ensures encrypted and authenticated sessions. Students and staff can also securely just, like as I said, access the school's app resources from anywhere, as long as they have a valid internet connection. Another reason to consider it is the IoT devices, Internet of Things devices, because IPv6 does allow for smart sensors, smart door locks, air conditioning units, HVAC units. I thought those were the same thing. Projectors, there's a spelling mistake there. Basically anything that can be automated or has a computer in it can have its own IP, like your calculator. If it has a computer in it, it's most likely going to have its own IP with IPv6, like a TV. And your smartphone also has it as well. I'm sure that's a shock to no one. Then the last one, cloud servicing, which does kind of just goes away with this one as well. Can't help you there. Kind of goes from this to this one, but let's go with this. Cloud servicing and remote learning. The direct IPv6 routing between student and staff devices and the school's cloud-based learning material system, LMS, I think that's what it stands for at least, will have reduced latency compared if you're trying to do some magical stuff with IPv4 for this. And it just can be used for secure remote access without VPN bottlenecks. Thank you for listening to my horrible thing about IPv4 and IPv6.